We're covering 8.3 Part 2 today. So we're actually going to add and subtract rational expressions. We prepared for it on our last lesson. So adding and subtracting rational expressions as well as simplifying complex fractions. You'll see what that means in a few minutes. This is probably the most difficult part of this chapter. So take good notes, pay attention. All right, first problem, add. So we've got two rational expressions. We want to add them. First thing we need to do, well actually first process is find the LCM or least common multiple, and then we're going to add them, and finally we're going to identify any x values which the expression is undefined. In order to find the LCM, we're going to factor. So this and we're only worried about the denominator, so this is for the denominator only. We only need to have a common denominator. So think about it. If we want to add 1/6 plus 5/12, we're going to get a common denominator, and we probably know the common denominator is 12. This one already has a common denominator of 12. We don't have to change that one. But 1/6, we need to multiply the bottom by 2 to get 12. In order not to change the value of the fraction, we're going to multiply both the top and bottom by 2. And that's going to give us 2/12 plus 5/12. And now, unlike multiplication, the denominator is the common denominator, so we don't add the two denominators, but we do add the top, so we end up with 7/12. Same exact process for rational expressions. So we're finding our common denominator by finding the least common multiple. We're factoring. This is simplified. This one can be factored into x minus 3. Nope, sorry. X minus 4. X plus 4, x minus 1. So here we have that one factored. And now you can see our greatest common or our least common multiple. We find each unique factor, which we've got x plus 4 is a unique factor. The highest power we have is x plus 4 to the first power. And then our other unique factor is x minus 1. And that's to the first power as well. So that's going to be our greatest common denominator, or our LCM. Notice this one, just like when we had 5/12, this one already has the common denominator, so we're not going to do anything to that one. This one, in order to make it the common denominator, we need to multiply the denominator by x minus 1. So we don't change the value, we're going to multiply the top by x minus 1, because x minus 1 over x minus 1 is 1, so we're basically multiplying this by 1. Alright, so we just multiply 2x times x minus 1, and this by x minus 1, and now just like before, we put everything over the common denominator, so we're not adding these two common denominators. The common denominator is going to be our denominator, but we will add the tops. So we've got x minus 3 plus 2x times our x minus 1. You want to simplify this by distributing and putting in standard form. So this would be 2x squared minus 2x. We combine our x minus 2x, put it in standard form, and that's going to give us 2x squared minus x minus 3. And that is pretty much going to be our solution. We can't really simplify that anymore. Probably it's okay to keep it in this form, but if you want to FOIL, you can also FOIL the denominator and get your quadratic. So that there it's fully added. Now we want to answer part 2, x values for which it's undefined. So if you haven't factored form, it's easier to figure out which x values would make it undefined. We're going to set those two factors equal to 0. So you have x plus 4 equals 0 and x minus 1 equals 0. What values of x are going to make these 0? Negative 4 and x equals 1. So that would be the last part of the answer to that question. Right, we're going to try another one. Add, identify any x values for which the expression is undefined. We need to find our least common multiple, or our greatest common denominator. So we're looking at these two. This one is already fully simplified. This is the difference of squares. So this can be factored into x plus 2, x minus 2. So if we look at all our factors in our denominator, we have an x plus 2, and the highest exponent we've got is x plus 2 to the first power, and then x minus 2 is our other unique factor. So these together are going to be our greatest common denominator. So this one is already has the greatest common denominator. We're going to have to multiply this one. Whoops. Actually, let me move that over a little bit if I can, so I get more room here. So this one is going to need to be multiplied by x minus 2 over x minus 2. And that's what they've done here. So now this becomes the greatest common denominator. And now they both have the same denominator. We're going to distribute that, and just add the tops. So that's going to be x squared minus 2x minus 8 over x plus 2, x minus 2. This isn't fully simplified because we can factor this. This can be factored into, what is it, x minus 4, x plus 2. And notice now we can simplify it by crossing those out. And so the final simplified answer would be x minus 4 divided by x minus 2. But when we want to find the values for which x is undefined, we want to look at this one. Whoops. We want to look at this one. So if we set both of those expressions equal to 0 and solve for x, we're going to find x is undefined at -2 and 2. All right, so there's one for you to try on the next slide. You should try this and make sure that you can answer that question. And we're going to move on to subtracting, which is really like adding, except you're subtracting, of course. So subtract those two rational expressions, identify any x values for which the expression is undefined. Again, first thing we do, factor. Whoops. We want to factor our denominators. This is the difference of squares, so it factors into x plus 3, x minus 3. This is x plus 3. So you can see our greatest common denominator is our combination of our unique factors, x minus 3, x plus 3, to the highest power that they exist in the factoring of any of those denominators. So it's just going to be x minus 3, x plus 3. This one already has the common denominator. We need to multiply this one by x minus 3 to turn it into the common denominator. So multiply top and bottom by x minus 3 over x minus 3. Now we have everything over our common denominator. We put our numerators. And don't forget we're subtracting. So we're subtracting this whole thing. So just be careful. Probably want to FOIL this first. So remember first, outer, inner, last, and that's going to get you to this. And now we're going to distribute our subtraction sign, and this is where a lot of mistakes get made. People forget to do that, and that's going to get us to this. And if we simplify, we've got 2x squared minus x squared becomes 1x squared. We have just the negative 2x, and then negative 30 plus 15 gets us negative. And can we factor this? We can. It can factor into x minus 5, x plus 3 over our common denominator, x plus 3. And you can see these cancel out. And this is our final answer. Values for which x is undefined. Remember, we want to look at it before we cross things out. So it's going to be where x is equal to 3 or negative 3. All right, I don't have an example because that's really just like adding. Just don't forget to distribute your subtraction. We're going to move on to simplifying complex fractions. So some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. And don't panic when you see these. They look more scarier than they are. Well, maybe. So you can see we have our numerator. Our denominator, however, is a fraction. So we've got a fraction within a fraction. Same here. We have a fraction in the numerator, and here it's got both a fraction in the numerator and denominator. So how are we going to simplify these? Here's our first one. Well, remember, this is basically a division problem. So this is, first thing you're going to do is rewrite it. X plus 2 over x minus 1 divided by x minus 3 over x plus 5. So it's basically just a division problem. What do? We flip over, take the reciprocal of this, and then do a multiplication. So here's our division. This is where we've turned it into the reciprocal. Nothing can be factored, nothing can be crossed out. So we just combine our tops, our numerators and denominators to get this. And save yourself some trouble and just leave it in that form. If you really want to FOIL it, you can, but it's just extra work. And that's all you do. That one was a fairly simple one. Let's look at another one. This one's a little bit trickier. It is a division, but we've got not only a division going on here, but we've got fractions here, and we've got to figure out what to do with those. This is basically, so what is this? Well, this is a division. This is also, well, this is just a rational expression, so we won't talk about that. But this is basically adding rational expressions. So we're going to have to add the rational expressions and then do the division, which is eventually going to be the multiplication. So how are we going to do that? The same way that we're learning to add. Let me actually move this up. So separate this problem into this part. First, we want to turn this into one rational expression. We've got to find the greatest common denominator, LCM. So the LCM, the unique factors in the denominator are going to be x and 2, both to the first power, so our GCD is going to be 2x. Okay, what do I need to multiply this by to get 2x? 2. What do I need to multiply this by to get 2x? X. So this is going to end up as 6 plus x squared over 2x. And I'm not really sure why they did it this way. This is not the way I would do it. So, well, now they've gotten to this part. So maybe what I'll do, you can look at this, but I'll show you how I would do it. So now we have 6 plus x squared over 2x divided by x minus 1 over x. And now we turn this into our division problem. 6 plus x squared over 2x divided by x minus 1 over x. Flip that over, take the reciprocal of this, 6 plus x squared over 2x times x over x minus 1. And what they did, so when they simplified, now I'm going to simplify. I can simplify by crossing this out, and that's about all I can do. So I'm going to end up with 6 plus x squared over 2 times x minus 1, which you want to rewrite in standard form, x squared plus 6, distribute this over 2x minus 1. Sorry, 2x minus 2. And that's going to be your final answer. So you can look at what they've done. I think ultimately they've done the same kinds of things that I did, but I think of it a little bit differently. I added my rational expression to get this, and then it turned into just a regular division problem. Okay, so you should try the following one. Make sure you know how to do that. And lastly, here's your homework. I know this is complicated, so you might want to bring some questions to class if you have them. Otherwise, I will see you in class.